Alright, here's solutions for perfect problem 6 from Math 251. Given a function, asked to find all critical values of the function. For part A, what you need to know is that critical values happen when you kind of need two criteria. You need f of x to be defined, and then you also need f prime of x to equal 0 or f prime of x undefined. The nice thing about this function is it's defined everywhere. We don't ever divide by 0 or take any square roots of negative numbers or anything like that. So we can kind of ignore this first criteria. To figure out the critical values, all we need to do is figure out when f prime of x equals 0 or when f prime of x is undefined. So to do those things, I guess we'll need to know what f prime of x is. So we're given f of x up here, so we got to take the derivative. If you take the derivative, what chain rule? Outside functions x to the 2/3 power, so bring that 2/3 down in front using the power rule. Leave the inside function alone, x squared minus 2x minus 8. And then subtract 1 from the exponent. 2/3 minus 1 is negative 1/3. But then you're not done. You still have to multiply that by the derivative of the inside function. Inside function is this polynomial. Its derivative is 2x minus 2. So f prime of x equals this mess, which you could rewrite in other ways, or you could leave like that. Sure, I'm going to write it in another way. Another way of writing this would be to take this 2 and distribute it into this to get 4x minus 4. And you can't distribute this 3 into this x squared minus 2x minus 8 because this is raised up to the negative 1/3 power. So if I put it on the bottom of the fraction, it's raised up to the positive 1/3 power, x squared minus 2x minus 8. That's to the 1/3 power. The 3 is not to the 1/3 power, so there's nothing I can do. It just stops right there. So a couple different ways you can write it. I think this will make it easier to write when you're trying to set it equal to 0 or figure out when it's undefined. A fraction equals 0 when the numerator equals 0. Technically it's when the numerator equals 0 and the denominator doesn't, but we're going to check over here when the denominator equals 0. So to figure out when f prime of x equals 0, all I got to do is figure out when 4x minus 4. Actually, let's write this more intelligently. So here's my derivative right here, and I want to know when this thing equals 0. But that will happen exactly when 4x minus 4 equals 0. In other words, when 4x equals 4. In other words, when x equals 1. I got a critical value when x equals 1. Technically, at this point, you don't know that x equals 1 is a critical value because we have to make sure that the denominator, well, no, I guess we don't because then it would be undefined. Never mind, x equals 1 is a critical value. Figure out when f prime of x is undefined. Okay, I know f prime of x, that's this thing right here. 4x minus 4 divided by 3 times x squared minus 2x minus 8 to the 1/3 power is undefined if 3 times x squared minus 2x minus 8 to the 1/3 power equals 0. Right? If you divide by 0, it's undefined. You can't divide by 0. So I need to figure out when this thing that's down in the denominator equals 0. Divide both sides by 3, you get x squared minus 2x minus 8 to the 1/3 power equals 0. Cube both sides of the equation, x squared minus 2x minus 8 equals 0. Solve this equation, I guess factor it. There's a couple different ways you can do that, but factoring is probably the easiest. Find two numbers that multiply to negative 8, add to negative 2, and that tells you that x equals 4 or negative 2. So what I have is that f prime of x equals 0 when x equals 1, but f prime of x is undefined when x equals 4 and negative 2. I got 3 critical values here at 1, 4, and negative 2. All that just to do part A. Part B. It's part B one from me. Classify the critical value at x equals 1, the critical value I found over here, as a local min or local max using the second derivative test. Alright, to find To use the second derivative test, I need to know the second derivative, f double prime of x. And that's going to be equal to the derivative of my first derivative up here, 2/3 times x squared minus 2x minus 8 to the negative 1/3 times 2x minus 2. Different ways you can write that, but let's just leave it like that for now. To take this derivative, we've got a constant of 2/3, you can pull that out in front. What happened there? Yeah, that's right. Okay. And then I will have product rule. Here's one function, here's the other function. Derivative of my first function, using the power rule, I'd bring that negative 1/3 down in front and get x squared minus 2x minus 8 to the negative 4/3. But then I wouldn't be done. I'd have to multiply that by the derivative of the inside function, which is 2x minus 2. So that's all just the derivative of this guy right here. When you're using the product rule, you take this derivative and you multiply it by this thing left alone, 2x minus 2. And then to that you add the derivative of this guy, which is just 2, times this thing left alone, x squared minus 2x minus 8 to the negative 1/3 power. Then I got 2/3 times that entire thing. This is f double prime of x. This is a mess. You can try to simplify this if you want, but you really don't have to, because we just need to know the sign of f double prime of 1. Right? You need to change all the x's into 1s. 2/3 times negative 1/3 times. See, if I stick a 1 in here, I get 1 minus 2, which is negative 1, minus 8, which is negative 9, to the negative 4/3 power, times, oh thank God that's a 0. If this wasn't 0, that would suck, because I'd have to figure out what this is equal to, but I don't because this is 0. Good. And this one's 0 also, plus 2 times, if I stick in a 1 here, I get 1 minus 2 minus 8. I could probably do that all in one step. 1 minus 2 minus 8 is negative 9 to the negative 1/3 power. When the dust settles, you got 2/3 times, this is all 0, plus, I guess, okay, I'll leave it, I'll do that in the next step, plus 2 times negative 9 to the negative 1/3 power. What that means is you have a negative 9 cubed root down on the bottom of a fraction. So it looks kind of like this. You don't need to know what this value is. All you need to know is this is a negative number. Right? If you take a negative number and you take its cubed root, you get a negative number. 1 divided by a negative number is a negative number. 2 times a negative number is a negative number. This is 2/3 times some negative number, which equals some negative number. In other words, f double prime of 1 is a negative number. It's less than 0. So what that tells you when you're using the second derivative test is that x equals 1 is a local maximum. Whew, that was a lot of work. That's just part B. Part C, maybe I'll do it on a new piece of paper. So we got part B done here. We classified this critical value as a local maximum. Now we have to classify these two. I think that's what part C says. Classify each of the other two critical values, 4 and negative 2, as a local min, local max, or neither, using the first derivative test. Alright, so I know that f prime of x is equal to, should have copied that down better, this mess, 2/3 times x squared minus 2x minus 8 to the negative 1/3 power. Can I remember all that? I can try. 2/3 times x squared minus 2x minus 8 to the negative 1/3 power times 2x minus 2. This was my first derivative. What I need to know is well, I have two critical values. I had one at x equals positive 4 and one at x equals negative 2. And what I have to do is figure out the sign of this thing when I'm a little bit less than 4 and when I'm a little bit bigger than 4. All right, so what I'm trying to do here is figure out if the derivative is at 4, if it's changing from a negative number to a positive number or a positive number to a negative number. And I think the easiest way to do that is to factor our derivative a little bit more. This is really x minus 4 times x plus 2 raised up to the negative 1/3 power times 2x minus 2. So if x is a little less than 4, if x is, sure, I'll write it, a little less than 4, we're going to have this positive number 2/3 times a little bit less than 4, like 3.9, minus 4, that's going to be a negative number. A little bit less than 4 plus 2, that's going to be a positive number. And then I'm going to want to raise that to the negative 1/3 power. A little bit less than 4 times 2 minus 2 is going to be a positive number. That's almost 8 minus 2 is almost 6. So what I get here is a positive number times a negative number raised up to the negative 1/3 power times a positive number. And what that is equal to is a positive number, well, a negative number raised up to the negative 1/3 is the same as 1 over a negative number, which is a negative number. So it's a positive times a negative times a positive, which is a negative. In the next so that's if x is a little bit less than 4. If x is a little more than 4, I kind of do this same analysis where I have 2/3 times x minus 4 times x plus 2 to the negative 1/3 times 2x minus 2. And I go through and do this positive negative thing. 2/3 is a positive number. Inside my parentheses here, raised up to a negative 1/3 power, I have a number slightly more than 4 minus 4 is a positive number. A number slightly more than 4 plus 2 is also a positive number. And then times 2 minus 2 is also going to be positive. It's like 8 or so minus 2 is about 6. So I have a positive number. Let me make this a little bit neater. Times a positive number raised up to the negative 1/3 power times a positive number, which is just a positive number times a positive number times a positive number, which is a positive number. So f prime of x changes from negative to positive at x equals 4. So x equals 4 is a local min. If we go through that exact same analysis with negative 2, maybe I need to switch colors. Same thing, same derivative. If x is a little less than negative 2, so negative 2.1, something like that. 2/3 is still a positive number. Negative 2 minus 4 more is a negative number. A little bit less than negative 2, so negative 2.1 plus 2 is still a negative number, just barely, but still negative. Raised up to the negative 1/3 times negative 2 times 2 is negative 4 minus 2 more. It's certainly negative. So I get a positive times something raised up to the negative 1/3 power, and that something is a negative times a negative, which is a positive times a negative. This is a positive times a positive times a negative, which is equal to a negative. If x is a little more than negative 2, same analysis, 2/3 is a positive number. A little bit more than negative 2, so now I'm thinking like negative, I guess I can do it on this one, negative 1.999. This is still negative. But this one over here, negative 1.99 plus 2, that's a positive number. Just barely, but it's positive. And so I want that whole thing raised up to the negative 1/3 power, and then times this thing out here, which again is negative. So that's a positive number times a negative number raised up to the negative 1/3 power times a negative number. That's a positive number times a negative number times a negative number. That's a positive number. So f prime of x changes from positive to negative at x equals negative 2. Wait, is that true? No, it changed from negative to positive. I wrote that wrong. Changes from negative, my answer up here, to positive at, this problem needs to end, at x equals negative 2. So x equals negative 2 is a local min. Kind of short on room if I were to graph this guy. Maybe I can squeeze it up top here. Part D. My graph is going to look like, let's see, at negative 2 I have a critical value, and at 1, 2, 3, 4 I have a critical value, and it's going to kind of have this weird shape where it has a sharp turn there, kind of pops up, and then it gets flat at 1, and then 1, 2, 3, 4 has this sharp turn again. I guess it turns outward. Looks something like this. So note that I have a critical value here, here, and here. Sure enough, local max, local min, local min. Did I write that right? It's a local min. Good. That is finally the end of this long problem.